Everybody, welcome back to another NumPy video. This is the second video in our mini-series on how to convert from binary to decimal. So if you recall, in the first video, we had this n by n NumPy array of zeros and ones, and we thought of each row as representing the digits of a binary number. And then as output, we want, well, what's the integer in base 10? So the purpose of this second version is just to show you a different way of thinking about it. So all I have here is just some code copied. So NumPy, of course, and the code to create kind of this sample array for us to use our function with. So there's ARR. Motivating the idea for this video is kind of this idea. So let's say I have int, and imagine I take this first row of ARR. It's 1, 0, 0, 1, so that should be 8 plus 1, that should be 9. So if I pass int a string, so let's say 1, 0, 0, 1, it says here, well, it thinks it's the number 1001. So kind of there's this assumption that we're using base 10. But something we can do is we can pass another argument to int. So we can say 1, 0, 0, 1, and if I say comma 2, this is saying think of this as a binary number. And now it returns 9, exactly what we expected. So just to show you, if I instead did int of 1, 0, 0, 1, and I said 10, so remember this is the default assumption, it just says, oh, well, this is 1001. So notice here we pass a string and we say just think of it as binary, and then it converts it for us. So using this idea, let's now say, okay, let's define z to be ARR of 0. So if we take a look at z, here it is. So same digits that I had passed as a string. Now the idea is somehow I want to kind of convert these to strings and smush them together. So one thing I could do is list comprehension. So I could say x for x in z. So now this just gives me a list, that's fine. But we really want strings, so I could cast each x to a string. And now it looks exactly the same, but each digit is stored as a string. Now all we need to do is kind of find a way of smushing these together. So I don't expect anyone to just know this, but the way we can do this is with a string method called join. And the way it works is I do 2 single quotes with nothing in between, dot join. And now I'm just going to paste this list comprehension. So we can see here, this returns 1, 0, 0, 1. So this is exactly what we want. So what we're going to do next is let's define a helper function that's going to be used to give eventually the tobin2 function that we want. So I'm going to define this as helper. As an input, let's say z, so kind of a row of our NumPy array. And we want to do exactly what we did here. We want to join all of the elements as strings. And then we want to return, so I can call this, let's say temp. Or yeah, let's call this temp. And I can say return temp. So we'll do something with this in just a moment. We'll update it to make it a little bit better. But let's practice a bit. So I could say helper of z. So this gives me 1, 0, 0, 1. That's looking good. What if we tried ARR of 1? So this should be 4 plus 1. This should be 5. So let's test it out. So I'm going to say helper of ARR of 1. And this gives me 0, 1, 0, 1. So that's looking good. Now remember, the way that we're going to get the decimal integers from this is by calling this int function and specifying that we're in base 2. So instead of returning temp, why don't we return int of temp comma 2? So then now helper z, remember this should return 9, there's 9. This should return 5, there's 5. So this is looking pretty good so far. So we have a function that works along, or we want it to work along the rows of ARR. So now all we need to do is put it in a function. So I'm going to say def tobin2. As input, we want a NumPy array, let's call it A. And what we're going to do is we're going to use np.apply along axis. So first, let's specify what do we want to apply. Well, we want our helper function. Then we want the array to be A. And what axis? So remember, we want to apply the function along the rows like this. So that's axis 1. Great, and what do we want to return? Well, we want to return this. So let's run it and let's try. So I'm going to say to bin 2 of ARR. And we can see here we get 9, 5, 10, 12, 8, 3, and so on. So let's see, the last one's 8, so that should be 1 followed by a bunch of zeros. So let's take a look at ARR again. So last element here, yep, that's 1 and then 0, 0, 0, 0. Then we have, this should be 2 plus 1, that should be 3. This is 4 plus 2, that gives 6. Then we have 8 plus 4 plus 1, that gives 13. So our function's looking pretty good. I think this is a good place to end the video. In the next video, we're going to talk about raising errors. And basically, we're going to be checking if our input satisfies a number of constraints. Thanks for watching, and I'll see you there.